So we are giving a presentation today about count and chaos engineering, the things we found while using it at count, and just what is chaos engineering. So first we'll start with, who am I? I'm Alan Morrison. I'm a QA manager at Count. I've been at Count for a little over 3 years, and we've been doing chaos engineering for a little over 2 years. And what is Count? Count is a software as a service company that's here in downtown Boise. We have a little over 200 employees currently. We're one of the leading providers of third-party digital fraud. And in February, we were actually acquired by Equifax, so now we're Count, an Equifax company. So why chaos engineering? There's a book called Accelerate by Nicole Forsgren, Jez Humble, and Gene Kim. They did a lot of research on the original DevOps handbook, and with this they did research on what does it take to build a high-performing organization. One of the things that they found was that in order to do that, you have to truly improve the tempo and the stability within the company to be high-performing. And the book gives you 3 principles that allow you to do that. For Count, a lot of our new software, when it was getting designed and built, we were all cloud-based, and we were looking at books like this, and how do we ensure that we are a high-performing organization and that the new products we're building are the most reliable cloud-based products that we can make. Did I skip a page? No. Okay. So how do we know that our tempo and stability is at a high measure, right? How do we know that what we're doing is going to be reliable? The book gives us a few different metrics that an organization should be tracking. They call them KPIs, to be able to ensure that, right, your tempo and your stability is where it needs to be. So how do we measure tempo? There's a couple of things. Deployment frequency, which is the rate the software gets deployed to production or your app store, depending on your product. And then change lead time, which is how long does it take for a request to come in from a customer to you actually delivering that out to the customer. For stability, there's a couple of additional ones. Mean time to recovery, which is when something happens to your software, how long does it take you to actually fix it? And then the change failure rate, which is how likely do defects occur, what percentage is that? At Count, we actually track 3 or 4 of these currently. We're still working on getting the mean time to recover KPI. There's a lot of data with that we're trying to be able to pull out of our monitoring and things like that to be able to track it appropriately. So the 3 key principles that the book mentions are chaos engineering, which we're going to discuss further today, game days, and disaster recovery. And just to give a little more information on the 2 that we're not going to go heavily into here, game days are more of a, how do you organize chaos engineering practices? What does it take to get a group of people together to be able to run that and do it proficiently to where everybody knows what's going on and how to manage, if errors occur, those kinds of things. And then obviously disaster recovery is doing that on a very large scale. When you're talking about working in the cloud, what happens if we lose a region? Are we capable of switching to another region? Are our customers just out of luck? So what is the best way to determine if your system can detect and tolerate failure? And that is through chaos engineering. With chaos engineering, we purposefully inject failures into our system to determine how it works. Does it work as expected, or are there things that we had no clue that were going to happen? And that is really what chaos engineering allows us to do. There are things that you know about your system, and there are unknown things about your system. Chaos engineering allows us to try to define the known things we think we know about our system, and then hopefully uncover the unknown things that we don't know about our system. So there are the things that we are aware of and understand on our system. Then there are the things that we are aware of, but we aren't quite sure why they work that way or understand them. And then we get into the unknowns, things we don't understand and we may not be aware of, or things that we don't understand, but we are aware of them. They're things that, so the things that we understand or not aware of in the system, right? That's what these experiments allow us to detect. With Count, all of our new products are cloud-based, right? And one of the big things with being a cloud-based product is, in theory, it simplifies a lot of what you do, right? The cloud provider takes care of some of that. The downside of it is the cloud provider takes care of some of that. So there are things that you have to understand for how they manage things versus what you're expecting, and then what you actually want it to do. So as Count started looking into chaos engineering and what we wanted to do, we went through and evaluated a bunch of open source tools and paid tools. And I'm sure if you go right now and Google chaos engineering, you'll hear about Netflix and Chaos Monkey and things like that, right? That they've really shown the light on what is chaos engineering and why it's important and stuff. When we did it, we actually found this tool called Gremlin that seemed to meet most of our needs and has been what we've been using since we've started. So Gremlin is a SaaS platform that allows you to do chaos engineering into your system. It can be used both on cloud in the cloud or on-prem. And it also has the ability for you to get to the point where you can schedule jobs. They have an API so that you can run jobs in your CI/CD pipelines. So you don't have to actually manually sit there for a game day and attack things and monitor actively. You can set this up once you know what you're doing and what you want in a pipeline and trigger them that way. So then how do we actually perform chaos engineering? Right? Chaos engineering is basically using the scientific principles to evaluate scenarios that you want to form a hypothesis on. So the first part of that, right, is we have to create our hypothesis. What in our system do we want to attack, and what do we think is going to actually happen when we do that? As we run the experiment, we want to measure the impact, right? Which means we need to make sure that we're able to measure the impact. You don't want to be performing this and not have the proper monitoring and alerting on your system. You want to define a rollback plan, right? If things go wrong, what are we going to do? Which is often why when you start this, you don't start this in production, right? You're doing this in a non-production environment. It's not going to be critical if something catastrophe goes wrong, right? You can break stuff and people are going to care, but not like your customers are going to care. From there, with these experiments, we're going to harden our systems, we're going to fix the issues we find, and we're going to have fun doing it, right? It's fun to break things. Chaos engineering allows us to do it in a organized fashion. So because running actual attacks live, right, there's a lot that goes into that. We're just going to walk through what an attack would be like. And Google actually has this Bank of Anthos app that is a sample app that they allow you to deploy out to their GKS to be able to, mess around and experiment with GKS if you've never used it before. And Gremlin actually has this set up so that you can use this app and their software to try out Gremlin to perform attacks and actually see what it does. So we're going to walk through what an attack on this service would be. So at a high level, this is the architecture of this app, right? It's got a load generator so you can push fake load through our system. It has a Python front end. As part of that front end, we have user services, contacts with a database, and then we have a Java side of the app with a ledger writer, a balance reader, transaction history, and another database. So this is a screenshot of what the balance reader portion of that app normally looks like. You can see it's got your current balance. It's got the ability for you to deposit funds, send payments. It's got your account number there. You can see that it has the test user, which would be the logged in individual for this account. So then what happens if we perform an attack on this, right? One of Gremlin's attacks they have within their system is called a black hole attack. So what happens if we perform this black hole attack on a critical service within that architecture, like the balance reader, and see what's going to happen to our customers? Right? Is it going to be an experience that our customers are still going to find useful, or are there going to be serious major issues, right, that we're going to need to design and do something within our actual system to fix it? A little more information on the black holing attack is it is a network attack within Gremlin that basically stops all IP packets from reaching whatever source you're attacking. Okay, so this is an example of what that page now turns into why we run that attack on this system. As you can see, we still have data showing up. We have our transaction history. We still get like the deposit funds, the sent payments there, but our current balance actually shows up with nothing, right? A customer would have no idea if they actually have money in their account or if this is actually an error within our system, right? The balance reader is having issues, which is why they don't have a legit balance there. In addition to this, we can test the other functionality on this page. What happens if a customer tries to deposit funds or send a payment while we're having issues with our balance reader portion of our application? So with this screenshot, you can see we click deposit funds. You can see up there it says the deposit was successful, and you can actually see in the transaction history, right, that we added a deposit to our account. So that still worked, right? If a customer tried that and we were having issues with our balance reader application, it would still work. However, when we click send payment, you'll see on here that we are getting an error message that is not an error message that a typical customer is going to know what that means. Somebody working in IT probably has an idea, right? That, okay, that's a connection error. We need to go figure out, why we got that connection error or a better way to handle it. A customer seeing that, they're going to have no idea why that error is being displayed or what they would need to do with it, right? We would want a better user message being displayed to them to let them know what occurred and if there is anything they could do with it. And this is where chaos engineering helps us out, right? We may not have known that we needed a customer-facing error message there. So some more examples of the type of testing that you would want to do with a game day are dependency testing, which is you determining, right, what are the critical dependencies for your software. As we showed, let me slide back here to this architecture. As we showed with this, right, balance reader was one of the dependencies for this app, which is why we attacked it. With whatever application you would have to look at the architecture and figure out, right, what we want to attack on there, what's critical, what do we think is not critical, but we still want to attack just to make sure things are handled properly. Capacity planning. This is a big thing if you're in the cloud to do, right? Not only capacity planning for what you know and want to configure on your system to be able to use, but AWS and Google, Microsoft, they all have their own capacity limits for things in your account. Do you know what happens when you get close to hitting those? Are they configured right to be able to scale for a spike on your customer usage? And is everything going to work properly? With chaos engineering, we can actually test that before we actually get there, right, and find issues with our customer. Auto-scaling testing, depending on what you're using for your cloud-based services or whatever, auto-scaling testing can be a big thing. We actually use EKS and EC2s for a lot of our stuff, so auto-scaling is a big thing for us at Count. And this is one of the tools, right, which allows us to test that. Some of our scaling is done by memory or CPU usage. And with this tool, we can actually test that without having to put the actual load on our system to spike those things. And then, like I mentioned earlier, disaster recovery, right? Ideally, you want to be able to plan for and test a disaster recovery scenario before it actually occurs. We've already seen multiple times in the last handful of years where, for instance, AWS has issues with a region or an availability zone, things like that, that you want your system to be able to handle and your customers not to feel that impact. With a tool like this, we can actually test that and make sure that our plans are set up accordingly and we know what to do when something happens with our cloud providers. Like I mentioned earlier, one of the reasons we chose Gremlin Eggcount was because of the breadth and scope of chaos engineering that it allowed us to do. One of the things we found when we were looking at various open source tools out there is in order to hit all the various types of chaos testing you want to hit, right? Resource, network, state, a lot of them were you either had to use multiple tools to do that or find like third-party plugins to add to a tool to do it. With this, we got them all with just this one tool, right? So everybody within Count that wants to perform chaos engineering can go to this one tool, learn this tool, and be able to do those. So let me quickly, while we're talking about it like this, let me actually open up Gremlin real fast. All right. So there we go. So I've set this up to show what we have in one of our dev clusters, just to give an example of what we would do here. And as you can see, we are attacking Kubernetes. We chose a cluster, a specific namespace for deployments within that cluster that we want to test. And then you can see the tool gives you a list of what it detects actually within that namespace. So we're just going to randomly pick one of these without actually attacking it, but just to show you what it does. As you can see over here, it now shows that we've selected this daemon set. It's got 3 pods in it. Right now, we would be attacking all 3 of those pods. You can actually change that to be a percentage base or a number of those pods, right? If for auto-scaling reasons or other stuff, you only wanted to attack a portion of that, you can easily do that within this tool. And then once you have your service or deployment selected, you actually then choose the type of gremlin, the chaos engineering attack that you want to run on your system. And like that previous slide showed, right, in here we can do resource attacks on the CPU, the disk, I/O memory. We've got the state process killer, which is legitimately what it says there. It'll shut down whatever service we have running, or shutdown, right? One of the things we want to be able to ensure with our auto-scaling is if we lose a container or an EC2, does our system automatically recover from that so our customers have no idea? You can easily test that right in here with that gremlin attack. And then, like we walked through on the sample app, right, there's the black hole. You can actually test your DNS configuration. You can add latency to services. One of the other big things customers will notice, and you'll notice when you're using cloud-based stuff for sure, is if there's additional latency between you and your cloud provider, there's going to often be a different impact on what your customers get, right? And that is not something that's consistent. So with this tool, right, we can add that and repeatedly test it to ensure that our system is working the way we want it to. And then packet loss, for instance. So once you actually picked one of these, you would then go in here and configure some specific settings for it, like length. How long do we want to run this attack? Right now it's 60 seconds. This one is the latency. So how much latency do we want to actually add to that service in milliseconds, right? Default's 100, but we could jack this up to add seconds if we wanted to. And then you can actually configure, various things on like the IPs or devices that we want to test. And then we would then come down here and click Unleash Gremlin, which would launch that attack. I'm not actually going to do it, but that would then launch our attack, where then we would go watch our monitoring and alerting, right, and see that our system's working the way we want it to. So let me switch back to the slideshow here. So with Count, we've actually, like I mentioned, we've been doing this for a couple years, and we have found quite a few areas within Count in our new systems where if we hadn't been running chaos engineering, I'm not sure if we would have found them until something actually went wrong, right? Like AWS had an issue as our cloud provider or something like that. Some of those are that we found several issues where dependent services weren't functioning, where our service wasn't functioning as expected when a dependent service wasn't functioning. And that is both our architectural dependent services and AWS services. We've attacked both where we found things may not be configured or working like expected. One of those areas is actually in retries, for instance. We assumed that our retry configuration for Dynamo, for instance, was working one way, and after performing experience realized that isn't what was happening and wasn't going to meet our needs. We had to actually build our own custom retrier to be able to get the functionality we wanted. A huge area where we've been using chaos engineering within Count and found it very useful is to validate our monitoring and alerting. Like I mentioned, when you create your chaos engineering hypothesis, right, you want to be able to monitor and know if you need to roll back, right? Well, you also want to be able to do that actually in production on your services and not wait for something to go wrong to be able to do that. So as we've implemented our monitoring and alerting processes, this allows us a way to test them, actually trigger alerts, right, where people within our office even get notifications, and for us to find that, hey, there's a hole here in our monitoring and alerting. We actually need to create different types of monitors than what we expected to be able to make sure we're covered. Much like that Java connection error in the sample app, right? We've also identified errors where we need additional requirements because we were not displaying something that a customer would find useful, right? No customer wants to find a connection message like that, or just a page that something goes blank on, or you're getting dashes when you're expecting a field, right? If something goes wrong, a customer wants to know it's not them. There's something that you're aware of that's being addressed. And then, like I mentioned when I discussed auto-scaling, it really has allowed us to do validation on our scaling, not only on our services, but because we use Kubernetes on our nodes itself, right, which is an area that's a bit harder to test. Yes, we can push a ton of traffic and load through our systems to be able to scale those nodes, but it's a lot easier to do it with this tool. And then within Count itself, what are we going to look forward to continue to do chaos engineering? Right now, disaster recovery, especially since we joined Equifax, is a much bigger thing. So as we define what our disaster recovery plans are, right, we want to be able to actually test that with this tool. And we're really looking to expand our usage within game days itself. Right now within Count, most of the chaos engineering is done by our QA team, and it's typically done on a much smaller scale, right? We're taking a particular service, attacking its dependency, or we're taking a higher level service and attacking 3 or 4 dependencies, right? We want to start getting into where we're having game days where, you know, we have groups across our IT that might be affected, and let's get everybody together. Let's make sure that if something major were to go wrong, we would all know what to do and our system could handle it. And then we're really looking to expand our use of it in our CI/CD. On our new platform, one of our big goals is to have CI/CD patterns that do a lot of our automated validation testing within the pipeline. And for instance, like on our monitoring alerting, there's no reason we should have to do that manually. We know what those tests need to be. We know what we're trying to verify. We want to be able to get that in our pipelines to know that, you know, as a new service is spun up, that monitoring and alerting is configured properly. And then just to wrap it up, here is just some general chaos testing resources that are pretty valuable. The YouTube is a link that will allow you to get further explanation on what chaos engineering is. And then I've included a few different Gremlin resources. They have a lot of resources on game days and chaos engineering that you could find useful if you've never done it and want to step into it. And then, like I mentioned, that sample app that we used in the demo, not only can you use that to, you know, try out GCP, but you can go try Gremlin and actually perform some chaos engineering firsthand to see what it's like and whether or not you would find it useful. And that is it. I am guessing because we're not live, there's not going to be many questions.